that's why I got into this field at all, was because in college I was studying physics because it sounded hard. This is just a bachelor's degree. So I'm studying physics, and we do like mechanics, and we do electricity and magnetism. And then like toward the end of the 4 years, we get to like quantum mechanics. And suddenly we can't predict anything with perfect certainty. Suddenly we have to do statistics everywhere and just guess. And it was like so unsatisfying. Meanwhile, in my last couple of summers in college, I did an internship where I was programming. I was programming in Arc Info, making maps. It was really cool. But the beauty of programming to me was that it was predictable, was that there was a reason for everything the computer did. And when it screwed it up, you could always find what was unexpected in like, oh, I didn't think this command meant this. I thought it meant something else. And then you can resolve it. And there's a reason for everything. Everything is going to execute in exactly one way. It was deterministic. It was a puzzle. Programming, like writing some code and running it on your machine, is like that. Fortunately, I got older, and now I love software because it's hard.
The other aspects of the complexity of coding that I certainly find interesting is I use the overly convoluted phrase maybe, but the kind of socio-dynamics of it. It's a socio-technical practice. We're doing technical things, but it's a collaboration of human beings that are required to achieve that. And that seems very, very important to be able to do a good job, and unless you are writing on small stuff on your own.
Right. I think a lot of what we try to do in how do we organize our teams, how do we break the code into processes, that the point of microservices is to try to get something small enough that it becomes a deterministic puzzle again.
Yes.
It becomes something a single person can work on without having to collaborate with others. That's a fantasy. Because you just push that complexity up into the social fabric and into the API calls where it's harder to see and harder to test. So I agree with you. There is no software without people. Oh yeah, there's that fascinating experiment at Twitter going on right now of how long can we keep this software running with most of the people gone. Maybe it's longer than I expect. I could be wrong. Every circumstance is different. But yes, like the resilience of software, what keeps it working, what keeps it safe, what keeps it growing in scale and adapting to the increasing expectations of it is always people.
Well, one of the things that I've read and I've seen you say in presentations and stuff several times that resonate strongly with me, because I've said very, very similar things, is that our job is not to write code. Our job is to solve problems for people with software, is the way that I tend to put it. That's what we're employed to do. We're employed to try and produce things that bring value to people that they can use or do something,
to provide valued capabilities. Our job is to provide valued capabilities to customers or internally to the business. Yes. And other people use those capabilities to solve problems. We don't solve their problems either.
Okay. So I.
It just feels so like, I don't know, egotistical or something to say, I will solve your problems. No. Okay. I can provide you capabilities that you might then choose to use to solve your problems.
Yeah. Okay. So I'm happy with that correction.
Okay.
So we're working. We're working to deliver something that can help people. To do whatever it is that they value. And that's our job. It's not the job of just writing software or
they're doing something that they value.
Yes.
And that's different from our values.
What I'm trying to get to one of my hobby horses, which is that I think that our discipline is about essentially a process of guided evolution. We need to structure a way of learning for all of us so that we can explore the problem, find out possible solutions to the problem, try out the solutions, see whether they work or whether they don't, discard the ones that don't, and try and improve the ones that do. And we do this on this iterative cycle where we kind of grow some capability. And to me, all software works like that, if it works.
I love that phrase. We're trying to structure a way of learning.
Yes. And I think that's one of the cornerstones of what it is, that what our profession should be. We should become experts at learning in order to be able to facilitate this kind of.
Right.
Sorry, I can't think. I'm too old school. I can't think of a way of saying this other than problem solving. But if you'll take my caveat, but you'll know what I mean.
Oh, well, yes, but see that learning isn't just us. We're structuring a way that other people can learn to solve their problems.
Yes.
And it gets back to what you said, if people don't know what they want, right?
Yeah.
How would we? We don't know anything outside of the context in which we actively need it. So observability is a great example of this.
Yes.
For my current topic of choice. So we're used to finding out what's going on in our software by looking at logs. And then we got graphs. And we like graphs because they tell us when something's wrong. They can't tell us what is wrong. And we're used to going to look to the logs to try to decipher that. Honeycomb's view of modern observability, and also we coined the term or brought it into software in order to say that there's something beyond logs and metrics. Whatever, the term doesn't belong to us. It's widened now. And logs and metrics are ways of seeing what's going on inside your software, so they count. Yeah. But there's something more than that. And there's an experience that if you've never had it, you don't know how much you need it. Yeah. And that is being able to go from the graph, click on an example, get a distributed trace, find the problem, see what's slow, ask, is this normal, get back to another graph. There's this way of navigating between the graphs and traces, which are better than logs. That if you've never worked with distributed tracing, and if you've never had that connection, if you've never been able to query any metric that you didn't previously label as a custom metric and pay for, you don't know what that experience is like, and you don't know that you want to do that.
Yes.
You don't know that you could be solving these problems in 20 minutes instead of all day. Yes. Poring over logs. And so that's an example of once you show this to people, then they can say, how would I know to do that? That I want to be able to zoom in. They can give you the details only in context.